Hello, this is question 7 on your June 2022 paper 2 from AQA. You have a curve y equals 15 minus x squared, so a quadratic, and the isosceles triangle OPQ are shown on the diagram below. Vertices P and Q lie on the curve, such as Q lies vertically above some point Q0. This is isosceles and this is symmetrical, so this point is going to be minus Q. Minus Q, the x is going to be minus Q. So that the area A of the triangle OPQ can be given by this expression. So let's going to find the expression for the area. It's going to be 1/2 of base times height. The base is going to be 2q. Yeah, if this is q and this is minus q, this length is 2q. That's the base, 2q. So then times by height. Height is this distance here. This distance here is the y coordinate of P and Q. And we can find the y coordinate of Q because we know the x coordinate and we know it is on the quadratic. Yeah. So if we substitute x by Q, we are going to find the y coordinate here. So the y coordinate of, or you can say that Q is Q, and then the y is going to be 15 minus Q squared. Which means this length here is going to be 15 minus Q squared. Yeah, that length. So I have base and the height, so I can say that the area is 2Q times 15 minus Q squared. I can cancel these two and expand the brackets, and it's 15Q minus Q cubed. That is what I have to prove. Yeah. For Q between 0 and C, where C is a constant to be found. I think you have two ways of reasoning this. The area must be positive. Yeah, and you can write the area as Q 15 minus Q squared. This must be positive. Therefore, Q is positive because we know it's greater than 0. So this bit must be positive, which means 15 minus Q squared must be positive, which means Q squared must be smaller than 15. So Q must be smaller than root 15. Yeah, that's one option. That's one option. Then the other option would be thinking that Q must be between 0 and something. So this is the maximum value of C. This point must be in the quadratic. So the maximum value that this Q can have is when this point is here. Yeah, if the triangle will disappear, it will be aligned, but we can become as close as we want. And we are not including the equal. So this triangle will be almost aligned, but the maximum value that this Q can have is this root of the quadratic. Yeah, and the root of the quadratic is what makes this equal to 0, which is precisely root 15. Yeah, so either way, I think you could think about it. It could be making the area positive, or just thinking that this value can go up to here, and this value is root 15. Yeah, so this root is root 15. So this is the first part. Then I would write that C is root 15 as the answer. Yeah. The next part says, find the exact maximum area of triangle OPQ. Maximum question. We have an expression in terms of Q. So to find the maximum, we are just going to derivate with respect to Q. So we are going to find dA by dQ. It's a polynomial. It's quite easy to differentiate. So we have 15 minus 3Q squared. 15 minus 3Q squared is going to be 0 to find the stationary points, which means 3Q squared is 15, which means Q squared is 5. Therefore, Q is going to be root 5. and we know q is positive. That's why we are ignoring the negative value. We have found the value that makes the area maximum or minimum, but we need to find the area, yeah, not the value of q, the area. So what we are going to do is to find the area. We have the expression for the area, which is 15q minus q cubed, when q is root 5. So we have 15 root 5 minus root 5 cubed, which is 15 root 5 minus 5 root 5, which is 10 root 5. That's the maximum area, but we have to prove that it's maximum, because it says fully justify the answer, and there is not a part C that say derivate again to check that is a maximum. That sometimes that happens in the question. If that doesn't happen and they say fully justify, they are expecting you to check that is a maximum and not a minimum. So we are going to differentiate again. We differentiate here, so we have minus 6q, that's my derivative, minus 6q, and then we are going to substitute the q by root 5 to see what happens in that point. So this derivative is negative, therefore is a maximum. Yeah, so that's what you have to do. You make the derivative equal to 0 to find the value of q that gives you the stationary point. Then you substitute in the area, you get the value, but then you have to check that that value is maximum. So you substitute in the second derivative your value of q and check the sign. You could do this before finding the area, but it really doesn't matter. Yeah, that's all with this question.